So, hello friends, welcome back to my YouTube channel Infinite Knowledge, and I am back with some unique concept and a unique final year project. You can consider this project for your diploma project or as well as your degree or ME project also. You can consider it a undergraduate project also and postgraduate project also. So, what the basic content of this project? It's a overcurrent relay and the short circuit relay. Using Arduino UNO, we are using Arduino UNO as a programmable device. You can program according to yourself. You can add overcurrent value as well as a TMS, time multiplier setting, as per your requirement. And as well as IoT device, we have used ESP32. By this IoT device, we can get an email alert or a telegram alert or a WhatsApp alert according to your requirement whenever your relay got tripped. So I am explaining just basic the diagram of the basic simulation of this project. So this is Arduino Uno. This is a programmable keyboard by which you can program your Arduino Uno. This is a main circuitry. This is a ACS712. Is a sensor that is used to sense the current, the RMS value of current. You need to sense because it's a AC current, and this is a secondary part of this simulation. It's just a stopwatch to calculate in how much time your relay got tripped. Why we are using this? Because we required IDMT characteristic. We are following standard characteristic, that is a IDMT standard inverse curve according to IEC standard 6022255. So according to definite time, IDMT means inverse definite minimum time delay relay. So when according to your current condition, according to your measure value of current, the relay calculate a time to trip, and specific time, after a specific time your relay get trip, and in between if your current is gone to under limit or under proper condition limit, usual limit of video, so your relay get not trip. So let's back to our presentation, and we will see all the things in the few minutes. So we are just going through the overview of this project. So this is a content of this part or this video, and all these things will be covered. And whenever I have completed my hardware model, I will also put the video regarding to the hardware model also. This is a totally simulation. And if you want these files, if you want this PPT, if you want the simulation file, if you want to remote report of this project, that's all the things is given in the description box. And this is the introduction part. So what is the basic introduction? Overcurrent relay are the protective device. Why it is protective device? Because it protect your system, your electrical system, your electrical appliances, your whole the electrical grid from any fault, any faults like line to line fault, line to ground fault. Here all the things is mentioned. So the faulty part of the system, whenever any abnormality occur, that is relay are. That's why when any abnormality occur, it's isolate the faulty part. And why it's called the brain of, that is why it's called the brain of the relay, because it is actually calculating and as well as sensing the value of current, and according to give the requirement or give the signal to circuit breaker or relay to trip and protect this system. So basic types of relay: electromagnetic relay, that is used in late 19s, and then comes static relay like transistors and diodes. All the things are covered, but nowadays we are using a numerical relay. Numerical means programmable device relay, in which we are using a microcontroller. You can program by yourself. It has an enormous amount of accuracy, of very good relay, and you can even add password also in this relay. So don't to so that no unauthorized person cannot access it. So by using the Arduino UNO as a programmable device, we can make the digital standard inverse overcurrent relay. Why we are using the standard inverse? Because all the relays are following standard inverse overcurrent curves that we will consider or that we will cover in next slides. This standard inverse curves of the overcurrent relay response inversely proportional to fault current. It means as your fault current is more, as your fault current is more, your time to trip is less. So you can see at y-axis the time and x-axis the current. As your current is high, your time is very low. And also the it's depend of the fault current magnitude. Okay, whenever your current is high, your time is low, and the operating time ensuring efficiency, efficient protection of the loads against the fault condition. Here we have considered overcurrent as well as short circuit relay. Short circuit protection is also covered in this relay by this relay. Uh, so usually during short circuit condition, your current is 5 to 12 times your normal current or your overcurrent. So whenever your current is increased in the system, it's a 5 times to the normal current. It will trip your system. It will give the command to the circuit breaker to trip in instant at an instant. It's a very fast way. There is no any cows follow by that time, just giving the tripping command to your relay to your circuit breaker when your current is 5 times of your normal current. So by this concept we have implemented 5 times as a short circuit. So this is a basic introduction part of this video. Now we are going to further slide, and we will understand the working principle of this relay, this numerical based relay. So, what is a working principle? A numerical relay is the latest industrial 4.0. There are four types of industrial segregation. Industrial 1.0 that was in 18 1800. Then 2.0 it was I think so 1920. Then 3.0 I think so it is 1968 nearly. And 4.0 I don't know exact value. I am speaking a random years. Random years, so don't consider it. What is the industrial 4.0? Industrial 4.0 is the industrial advancement automation. We are on the automation stage, we are on the next step, we are on the futuristic state. In industrial 4.0 represent it, we are on uh, advanced level. So numerical relay is the latest industrial 4.0 based advanced microcontroller based IoT relay, and it is the fastest as well as accurate as well as reliable relay compared to electromagnetic relay. Electromagnetic relays are conventional relay in which coil was used, and whenever current is flow, electromagnetic rotate the disc, and due to rotation of the disc, your contact get close, and this is a very complex method we was using whenever we were using a electromagnetic relay. But now it is replaced by the numerical relay, numerical advanced relay. Basically, in this relay, current sensing sensor have been installed and used to sense the current as an analog value. It's need to convert in the digital value. So it's analog signal. So always your current is your varying quantity, and all the microcontroller and microprocessor don't know the varying quantity. They just know 0 and 1. So we need to convert this value in the 0 and 1 pattern, 0 and 1 patterns to understand. That's why we have used analog to digital converter. And for the sensing the relay, different sensors are used here. For basic model we have used ACS 712 sensor. It's working on the whole effect. That is all the things how this working. It's all the things very crystal clearly explained in my report, or cover in my report. So the digital signal is converted and it is given to the processor to process the signal. To processor check the current value whether it is in the limit or not. So first of all it will check whether it is limit. What is the limit you have add whenever you are using a relay? You have a specific overcurrent value. So you need to add this overcurrent value first of all in your relay. So and first procedure of my processor is to check the current is more than overcurrent or not, added value. So if it is overcurrent, that it will calculate the time to trip. And in between, if your current is very high, greater than 5 times, as we explained in as above slide, if it is greater than 5 times, then uh, it will generate an instant tripping to your breaker. So this is how basically it's work. Analog signals come to processor. Processor check the current and calculate the time. And after a specific time, it's give to signal to the output relay. And output relay, your output relay will operate your breaker, and your breaker get tripped. If major current is greater than 5 times of credit. So this is a basic working principle we have covered. Now we are going to further. So this is a basic block diagram of Arduino based relay. So here is a 220 volts, it's a 230 volt system. It's the ACS 712 current sensor. This sends the current and give to the value to the Arduinos to calculate the time. We can interface Arduino with a keypad and LCD that we have already shown. And this is a SPDT relay. It's a one type of relay to isolate your electrical circuitry whenever a command is generated by Arduino. This Arduino UNO, it's a programmable device where uh, we are using Arduino and we add So for the Arduino program, the program of this Arduino so given in the description box, and all simulation file report and PPT is also available in the description box. The SCH 712 Hall effect sensor because it's working on the Hall effect principle as per the magnetic field. Uh, um, as whenever current flow through, how this work, current flow through this system like this way. These two terminals are here, this way. These two terminals are here connected here, and amount of current it will generate magnetic field, and the, the capability of this magnetic field, according to intensity of this magnetic field, it's calculate the signals and give to the Arduino Uno. By this way we can get what amount of current that is flowing through this system. The basic block diagram. Now we are going to the forward further. So now we are checking the simulation that we have made in the simulation software. Just I have gone through some slides, and then we have switched to the actual model. So this is a main circuitry. You can see very clearly. This is a 12-volt lamp. This is a AC supply, and this is a current measuring ammeter, and this is a sensor, and this is a relay, and this is Arduino, and this is a interfacing device that we have already gone through. So whenever you start the simulation, these types of interface is visible. Here you can see you need to add the value of current. You need to add the value of current, like what overcurrent value you need to add. You can use this keypad to enter any value, any number of value you can enter, like 1, 2, 3, and then to select that value, you need to press this button. This is a button by which the added value will be considered as a overcurrent value. So once this button is pressed, again another display is available. It's a TMS. Now you need to add the TMS. What is TMS? What is all the things? We will understand in the next few slide. What is the standard curves? What is the formula for standard curves? How this system is work? We will all the cover in the next. So this is a basic concept of this. Circuitry that we need to understand. That's why I am explaining it. And this a TMS is a time multiplier setting. And if 1, 2, 3, all these buttons you can use to add the TMS value. And once you add, you need to press positive button, this button. And if you press this button, this value is considered, one is considered as a TMS by this Arduino. And now your system is healthy. It is checking your system. If the system is healthy, relay is on. It means your circuit is working properly. During working condition, this message will always be visible. But but this is a circuit, and whenever any trouble happen in this circuit, whenever any trouble happens in this circuit, the microcontroller will generate a tripping command to the relay and isolate this faulty part, and relay trip message will be displayed. To reset this relay, you need to press this button for a once, and you will again come to your basic position like on this position. Again, you need to add current and EMF. So according to this basic logic, this concept is working, and just gone through some basic calculation part that need to understand or need to know because it's a this is a formula that we are using. It's a standard inverse curve formula for IDMT curves as per IC standard. IC is the International Electrotechnical Commission that are generating different standard and different procedure to operate electrical or how to operate and organize electrical system. So here for this specific system, I have I have added 3 ampere and TMS is a 1. And this is a formula. So time to trip formula, and it is totally calculated by your Arduino. And this formula has been added in program. So what is it? TMS into 0.14 divided by I raised to 0.02 minus 1. What is I? It's the actual current divided by overcurrent setting. So here overcurrent is 3 ampere. So I mean I is equal to divide by 3. But what is this value? This value actual running ampere. So if your running ampere is 2, then I is 2 by 3. And if your running ampere is more than 3, like 4, so then it's a 4 by 3. So during this condition or by this way, this time will be calculated. And according to this time, particular time, after a particular time your relay get trip. So this is a basic concept. So now I think so to understand this table, we need to first understand how this model is work and all the things very clear way. So we are going back to our main model. So let's take this simulation, how this simulation is work. I have started the simulation. So whenever you start the simulation, you need to add overcurrent value. So according to this time to trip formulas, what you need to add overcurrent at 3 ampere and TMS is equal to 1. So I have to add a 3. 3 is the overcurrent, and by pressing this 3, you need to press this button. So whenever this button is pressed, the 3 was considered by Arduino UNO as a overcurrent. Now you need to add TMS. You can add any value of TMS. 1 means zero point 0.1, 2 means zero point 0.2, 3 means zero point 0.3, because usually a TMS in between 0 to 1 range. And whenever you press 0, it will is consider a 1. And then you need to press this button. So if I am simulate is once again, if I stop this, you can add any random value. So when I have started the simulation once again, you can add 99 overcurrent, and then you need to press this button. Whenever you are adding current, you need to press this button. And if you want a point 0.1, 0.5, like consider a zero point 0.5, it's a zero point 0.5 T. Whenever you press this plus button, zero point 0.5 is considered as a TMS by this Arduino. So these two basic setting and very important setting that is considered by Arduino, and according to these two setting, your time to trip calculation will happen, and the time to trip calculation is depend. And this is how is circuit start, and it's a circuit breaker. Whenever I start the circuit, it's a circuit calculation time, how much trip. So it's taking 5.28 ampere, and you can see here it's a serial based communication, and your system is in healthy, so your current is overcurrent is a 99 and actual current is a 5.28, so it's a very low. So according to this time to trip formulas and time to trip condition, I have defined different table which we have followed this first one. So what is lamp resistance? 1.5. So it's a 1.5, no, it's a 1.1. So I have changed the 1.5. Okay, then port resistance zero point 0.7, it's a zero point 0.7, no, it's a point. So I have changed the point. Okay, then what is current flow through this system? 3.66. So I need to check the current flowing to. So if I am checking, it's 3.66. Okay, nearly 3.6. Current is flowing nearly 3. And I need to check. So here there are two column. One column is time to trip using calculation. If you use this calculation, you use this formula, then what is the time to trip? It's a 35.13 second. And in simulation, what is the time? So 35.3. It's a very nearer. We are getting 0.2 to 0.3. Just like very low error. And I need to add these points also. Uh, we are getting plus and minus 0.2 second tolerance by this program. You can consider because it totally depend on the Arduino program. So I have used program or as project because I have made the project. Okay, so I hope you can calculate this 35.13 by this formula. What is it's needed? Okay, I have forgot the TMS here, but you can consider. Okay, according to this formula, this is the same formula you need to calculate. And what is a TMS? Here TMS is a 1. Here for this TMS is a 1. What is 0.4114 is a standard. What is I? Actual current divided by overcurrent. So overcurrent is 3 and actual current is sensed by your Arduino whenever your circuit is in the simulation. And according to that way, in the running simulation, in the real-time simulation, we are calculating the time. Arduino is calculating the time, and according to a specific time and according to specific time delay, your relay gets tripped. So this is first one. It's the 1.5 lamp resistance we have already added. Zero point 0.7 port is already added. Zero point 0.7. And now we are checking the time to trip. So I am starting. So I am starting the simulation. Okay, and I have to need 3 ampere and one as a TMS. And now everything is okay. Everything is okay. And your current is already high, 3.6. Okay, it's a more than 3. It's a more than 3. So now you need to focus on this. After 35 seconds, after specifically 35 seconds, the relay will get tripped. So we need to wait because we cannot do anything. It's take a 30 time. And it is checking the real time simulation. And according to your real time current, it is generating the tripping. So let's wait. Okay. So it's a very nearer 35.6 and we are getting 35.13. So there is some tolerance and due to this simulation takes some time to run, but you are getting a very proper way by this. So according to above mentioned, you can calculate this time for all the things and you can verify it with actual simulation time and time to trip using calculation. So we are just verifying for this fifth one also. So what is the lamp resistance 1.1 and what is the port resistance of 0.2. So this value is already added by me. Uh, okay, so you can check it's a 1.1 resistance that is a for lamp resistance and this is a 0.2 for the port. And again I am simulate this project and check the time. What was the time to trip? It's a 10.25 according to your calculation, and it's a 10.7 according to your time to trip. According to your simulation it's nearly 10.7. So I am adding the value current 3 and 0 as the TMS. So if you add any wrong value, you can use this reset button also. Whenever you press the reset button, your simulation was start from the zero, from the zero. So once again you need to add current 3, you need to add the TMS. So your system is in healthy condition and your ampere is 0 0. Whenever you press the current switch, once it start to calculating the time, your current is more than your added value 5.87, 5.91. It's a very high current compared to your added current. Your added current is just a 3 ampere. It is taking a 5 ampere. It's a 2 ampere more than it. According to calculation time, it's nearly a 10.28. So what is it's a 10.7. So it's also very nearer due to the simulation time and it's very. Or you can check this stopwatch also. This stopwatch program is very clear, and if you want to check it with compare with this time, compare with this time 0.6, 0.7. If I am hold, you see 1.54. It's a 1.5, and if I start it once again, you can see this two times is very clearly matched. So this this switch stopwatch is very perfect, very precise. Okay. So this is how you can made and you can make and you can verify this relay. You can make this project. This is a lamp resistance and this is base. This is a base and basic consideration to calculate your time, followed by standard inverse curves. These the standards. And this is time to trip. It's a very nearer. You can consider, you can change this to 2.5 because we are getting plus minus 5 seconds tolerance. Even though it for plus minus 5 for us, our accuracy is very high compared to electromagnetic relay, and you can even program by yourselves also because it's totally depend your value, because you need to add what is the current, you need to add what is the TMS, how this simulation. And whenever you have made the actual model, you don't need this stopwatch, you need just remaining model. This will remove. Okay, so now we are checking the short circuit condition. Whenever short circuit happen, whenever is your current is greater than 5 times your added current. Here added current is a 1 ampere. Whenever fault happen, 5.91 current will flow. 5.91 current is a very high. and it is a 5 time. At this time, program Arduino should not wait for time to trip. The Arduino will not wait for this value, for this calculation, and it will directly generate the tripping command. It will take 0.2 seconds. Why 0.2 seconds? Because number of instructions are added in the Arduino, and all the instruction takes some time to simulate. Arduino takes some time to understand each and every instruction. It's a this time is very low. It is in the microsecond, but overall all the instruction due to that way you are getting very minimum time to trip. It's a 0.2 seconds, so very less. So we need to check for this one also. 1.1 and 0.2, 1.1 and 0.2. So already added the register value. So you need to just add the current value here, and it's a 1. In previously we are using a 3, but we are using a 1 because your current in it's a 5.8, and if you add 1, so 5 times we have considered a 5 times, so short circuit condition will be created. Okay, so you need to add 1 as your current, and you to add 1 as a T. So now circuit is in off condition because I did not switch on the secondary. But whenever I switch on the secondary, at a very instant, take a 0.8. At a very instant, time to it get tripped. This is simulation taking very time. Even my print decoding is also working parallelly. That's why this simulation take more time to simulate, but it's a very accurate in the hardware mode. Okay, so once again we are checking it. This what is the overcurrent? One. What is the time to give it? So also not a zero, it's a one. And whenever you place this switch, you can see very instant point two, very instantly trip. This is how the protection is happen on the short circuit as well as overcurrent. So you are getting the 0.2 second also whenever short circuit. So this one is our standard inverse curve according to IEC standard, and according to time to trip characteristic IDMT relay, we can calculate the time. So this is a formula that we have already know, and what is the actual current and overcurrent setting is also you know. Overcurrent means you have added value whenever you are starting your session or you are starting uh, your project, hardware project. This current value is 3 for this one. We have considered a 3 because for this setting we have calculate all the curves for all the different time TMS, time multiply setting 1.5, point 8, point, and whenever your current is greater than 3, and whenever your current is greater than 3, it's a 3.2. So relay take 108 second to, it is a 3.8, it's a 29, 4, 5. As your current value is increased, your time to trip is decreased. Time to trip, the time taking by Arduino to trip the relay is decreased. So for a 9 ampere, for specifically this setting, if your current is 9 ampere, it will trip your circuit in 6.3. And for specifically, you need to add a point 0.5. Point 0.5 means this TMS. So your time that you are getting, actually half of this value is this one. Then you need to add like point, it's just a time to take. You can set the time according to your requirement, point 0.8, point 0.5. So by this formula, if you are getting 108 second but you want to trip in very fast way, or like if you want to trip in just 50 seconds, you can change TMS value 1 to point 0.5. So it will just trip in the 54 seconds. So according to your requirement, you can change TMS value. That's why TMS is very important. And for all the TMS graph, I have uh, made the Excel. I have made the graph in the Excel, and you will get the Excel file also. And you can see very clearly when TMS is high. As your TMS is low, time to trip on the current is very low. For specifically 4 ampere, you can see you can get 4 different time to trip. according to your TMS value. So when TMS is high, your time to trip is high. When TMS is low, your time to trip is low. So by changing TMS, you can change your time to trip. If you want to see this Excel file, so this is specifically for overload current 3 ampere and TMS for different TMS and different time to trip is also mentioned. So you will get this Excel file also in the description. So you know here, or you can see here, we can generate an alert whenever your relay got tripped. So whenever any tripping happen, whenever this type of tripping message is displayed on the on the relay, at the same time the email or as a WhatsApp alert or as Telegram alert will be generated on your mobile phone, and on your at a time on your mobile phone you will get a notify by this ESP32 module. Just this module required a internet connection or a Wi-Fi connection. So by that internet connection, it will generate an email or WhatsApp alert or a Telegram alert. So protection relays are connected in the electrical panels. Okay, obviously they are connected in the electrical panels, and these panels are installed at a remote location or on the plant area. So it is on the remote location, and sometimes you cannot access easily, or you are not checking the performance of the relay day by day base, because it is creating unnecessary time consumption. So you have implemented IoT device on it, and whenever you any abnormality, you will get notification at a time. So you will not you will get aware about what happening at the same time, and you don't need to check all the times this system, and therefore sometimes unable to find where actually trouble is happening. So whenever the number of relays connected in the system, you cannot even distinguish which relay is tripped. So if you install this system, it was all the relays, and all the relays have a specific number, so you can easily identify which relay got tripped, and you can easily resolve the problem in minimum time. So this is a very important feature of this IoT device and IoT simulation. To get rid of the temerarious situation, need and specific time when a trouble happen. You can get at the same time can get an email. At the same time, the ML should be generated and respectively device like a mobile phone or a personal computer. For getting alert, we are using ESP32. ESP32 is also Arduino based module, and you can easily program it. And it's a Wi-Fi upgraded module of Arduino UNO and very easy to program. And you can consider it is as a IoT device. So this is the email that is generated by this ESP32. I have made the system. You can see here, I have made the system and I have connect the relay to a digital input D0. And whenever digital input D0 is getting high, I will get this email. And this is generated mail. This is how your alert team, you can modify this all the text according to your requirement mail generated on the relay trip, and you can I relay 1 relay 2 relay 3 according to your requirement or your condition or naming of your relay. So email alert on mobile phone. So this is three media by which you can get a mobile phone alert. You can use email also. Obviously, WhatsApp alert is also possible. On Telegram alert is also possible. But all the programming for the ESP32 programming is also available in the description box. For all the things, for email also available, for WhatsApp also available, for Telegram also available. You need to be very clear about it or on which you want the alert. So this is how you can upgrade these relays, how you can upgrade this relay as a IoT relay, and this is a actual simulation, actual circuit diagram of this simulation. So you need a two program. For one is Arduino and for one is a ESP32. And if you are using a stopwatch as mentioned in previously, then you need a 8051 programming also. So all the programming, all the simulation file, all the necessary thing is available in the description box. And these are some reference. I have used research paper and some uh, IEEE papers. And thanks for watching this video. I hope you learn very new things, very unique things by this video. And I am very damn sure this project is very helpful for your academic growth. And you can buy this project in the buy the project by connecting the email ID that is given in the box. And you want whenever I complete the hardware of this project, I will put video of that hardware project also, and I will explain all the things very clearly. Same I have explained in this video, same in the simulation. And once again, if you have any electronics project, Arduino project, MATLAB project, you can connect with me for any type of project, for any type of simulation project, or for any type of hardware project. You can connect with me through my email ID that is given in the description box. Thanks for watching this video.